So hello guys, welcome to the first lecture of the series of lectures of sets. This is a very important chapter and this is actually the barrier to higher mathematics. I don't know why it poses a barrier to higher mathematics. In modern mathematics, many theorems are actually proved by the help of sets, relation functions. So this is a very important chapter and very crucial chapter. So now let's start with the definition. So what is a set? There is no, again, there is, I'm sorry to discourage you, but there is no formal definition of sets. But a very informal definition of set is that a set is an unordered collection of well-defined objects. I don't know what is quote unquote unordered and what is quote unquote well-defined. I don't know what this means, but that's how a set is defined in more informal way, that it is an unordered collection of well-defined objects. Okay, so a set is defined by curly braces. A set is represented by these curly braces, and objects inside curly braces are called elements of sets. So these are elements of sets. Okay, so let's take a few examples to understand sets. So is this a set? So we'll look at the elements. So the elements are 1, 2 and 3. Okay, so they are unordered and well defined. So yes, it is a set because we can say that this is a set of first 3 natural numbers. Okay, so it is a set. Let's take another example. Is this a set? Yes, there is no ambiguity about it. This is a set that contains first 3 natural numbers and first 2 letters of alphabet. Okay, so this is also a set. There could be a set like this: Mercury, Venus, all the way up to Neptune. Is this a set? Yes, it is a set that contains all the planets of our solar system. So it is well defined and unordered. So this is also a set. Now, is this a set? Let's take another example, and let me write it. Is this a set or not? Now, this is not a set because the word beautiful is a very subjective notion, and कोई चीज़ किसी एक के लिए beautiful हो सकती है तो किसी दूसरे के लिए ugly हो सकती है, and we can't go with contradictions because beautiful is a very subjective notion. Therefore, it is not a set, and it is not a set because it is not well defined. So therefore, it is not a set. Because again the same logic, कोई एक चीज़ किसी के लिए beautiful हो सकती है, किसी के लिए ugly हो सकती है. Therefore, it's not a set. Now we'll look at some of the notations that are very useful in sets and that are very often used in sets. Okay. Now let me introduce the notion of belonging. Okay. So for a set S and any object A, one can ask whether A is a member of set S or not. So if A is a member of S, then we can say that A belongs to S. We can say A is a member of S. We can say A is in S, or we can simply say A belongs to. So this symbol, that is actually a Greek letter epsilon, this means belongs to. So if it is written that X belongs to Y, which means that X actually is a member of Y, or X is an element of y. So this means that A is an element of set S. Okay, so that's the notion of belonging. And if for some cases we can say that if A is not a member, is not an actually element of S, then we will write this as A does not belong to S. So this technique is very helpful when it comes to proof, because in proof instead of writing these statements, we can simply use these symbols to reduce the effort. Okay, now we will look at some of the other notation and very basic and fundamental sets that may appear every time. Okay, so these are very basic sets which we are familiar with. So this is a set of all natural numbers. This is set of all all integers. This is set of all complex numbers, and Q is actually represented. Q actually represents set of all rational numbers. So this should be kept in mind. Now let us define some of the very basic notations that shall be used in mathematics. So let's talk about a few notations that shall be used frequently in mathematics. So first is this. This means that belongs to. For example, we can say that x belongs to A, which means that x is an element of A. Okay, so it means that x is an element of A. The second notation is this, the inverted A. This means that for every, instead of writing for every in a proof, we shall write this. For example, we can define that as for every x such that and so a condition. Okay, so that's how we define for every. And then there is a set of, we define something like this, which means that it's a null set. Okay, it's a null set. So example, if it is written that x belongs to phi, which means that there is no solution for x, there exists no x. Okay, so that's a null set. And there are a few more symbols that we shall use, or notations that does not belong to, does not belong to. Okay, so if you write example x does not belongs to y, we are simply saying that x is not an element of y, and then there will be a notation that will be used, that this, it means that there exist. Okay, so instead of writing there exist, we shall use this notation to reduce our effort. So we can write that there exist x for which, and we can define a function on this which satisfy this. So these are the notations that shall be used in mathematics at our level. Okay, now we'll talk about representation of sets. Okay, so let's get started there. Now let's talk about a representation of sets. So let's take an example for that. So let S be a set of all even natural numbers. So we can represent this in two forms, and the first form is called the roster form, in which we simply write all the elements. Okay, so starting from 2, 4, 6, 8 all the way, so we write all the elements, and just by its appearance we can think that this is not a good way to represent a set, because there are infinitely many elements in the set, and we, of course, we can't write all the elements. So this is very hectic and very kind of space consuming and time consuming way of representing a set. So a new set representation was developed, and that was called a builder form. So, and that's called the builder form, in which we define a number which satisfied by all the elements of the set. So we define n, where n belongs to natural numbers, and 2 divides n. So that's how we define a set in a builder form. We just define a number, an arbitrary number, and we put conditions which is satisfied by all the elements of the set. So that's how we define a set in a builder form. Now let's take another example to understand this. So here is another example which says let S be a set of all natural numbers less than 100. So to represent this in roster form, we will simply write the elements. इसको रोस्टर फॉर्म में रिप्रेजेंट करने के लिए हम सिंपल एलिमेंट्स लिख देंगे, जो कि 1 2 3 4 ऑल द वे अप टू 99, because we are being asked to write natural numbers less than 100. But this is a very hectic and space consuming, and this is not a good approach. So builder form is always available to us, and we can write this set as n, and we can define n is element of natural numbers where, and we put one more condition to n, that n is less than 100. So that's how we define a set in roster form, in set builder form. So I think the way to represent a sets, there are two ways: roster form and builder form, and I think it is clear with the help of these two examples.